Morning, everyone. Good day. So I'm going to tackle on the answer keys of the quiz that we had last time. Okay, so let's start with part one, number one. It says here, letter A. The sequence of a limit is convergent. And the second is when the sequence is a limit, its series is also convergent. Okay, number one is true. No? So when we say if the sequence is a limit, then we could say that the limit that the sequence is convergent. So A is true. However, it does not mean that the series is convergent. We know, uh, uh, we know from the previous lesson that we had, when the sequence has a limit L, or if it's infinity, the sequence is divergent. We can only say that the series is convergent when the limit is equal to 0, but that is subject for testing. Okay, it's also subject for testing because there are some series where the limit is 0, but still they are convergent. Example for that is they are still divergent. Example for that is sequence 1 over n. Okay, number two. Number two, the question is this one. Given that AN and BN are bounded sequences, then AN plus BN and also the sequence AN times BN is also bounded. Okay, this statement is both true. No? So the function, so if both function, anyway, a sequence is a function. So if both functions are bounded, then the operation of these two functions is also bounded. Number three, a monotonic sequence is a bounded sequence. Bounded sequence is a monotonic sequence. Okay. The first statement here, a monotonic sequence is a bounded sequence. Okay, this one, that is false. No? Okay, let's take for example uh, the sequence of the set of natural numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So though it has a lower bound, but it does not have an upper bound. So therefore, we can say that that kind of sequence, a monotonic sequence, is not a bounded sequence. Okay, a bounded sequence is a monotonic sequence. Okay, this one also is false. Example of this is the alternating sequence -1 to the power of n over 1 over n. No? Though it is bounded from 1 to 0, it is bounded from 1 to 0, but it is not monotonic. So therefore, this statement is false. Number two. So both statements are false. Let's have number four. If a limit an is equal to L, then an is convergent. And B, if a limit of an is equal to L, then the summation an is convergent. Okay, this statement is similar to item number one. Actually, it's the same as this one. No, so it's the same as this one. So therefore, since false man siya, and this is also false. So this item is also false. Okay, that's the last number. The last number. Okay. In your so we know this is an example of P series, no? P series where P is equal to one, then P is equal to two. Though it is in the statement, it's in the definition when n is greater than or equal to one, uh, the sequence must be convergent. However, for the case of 1 over n, 1 over n, that is divergent because summation of 1 over n to the infinity, if you try to recall back in your um, calculus 3, calculus 2, the definition of uh, the integral or summation of uh, 1 over n from n is equal to 1 to infinity, that is equal to ln n. That is equal to ln x or ln n. So ln n is equivalent, that is equivalent to, if the limit of ln n that is approaching to infinity. So therefore, the only statement that is true here is only letter